Well, hi once again. This is the Maths Jedi channel, and this is another of my videos in the A-level series. This one is dealing with some questions today. So if you've been tuning into my channel, you'd have seen this week I've had videos on hypothesis testing and two-tail testing, and this is just finishing off that particular topic, really just going through some questions, exam type questions from the textbook that people might find useful. So if you are doing Edexcel A level, you might find this particularly useful. If you're new to the channel, I'd really appreciate it if you could subscribe or leave a like. That would help me out a ton and support the channel going forward. I appreciate we're all at home at the moment, shielding from the coronavirus, but I'd be really appreciative if you could just drop a couple of seconds just to drop me a like and help out the channel going forward. So without further ado, let's just go into some of the questions that we're going to look at today. All these questions are from Mixed Exercise 7. That's page 110 in the textbook. So if you want to take a look in there, you'll see those. But you can see them on screen, and I'll highlight them to you just to see what these particular questions are talking about. So we're going to focus just on a couple of these. We're going to focus on question 4 and question 5 to start with. So question 4, first of all, this particular question is dealing with the proportion of defective articles being 0.1, the random sample size of 50. As with other questions that we've done in this chapter, it's going to be primarily dealing with a binomial distribution. This binomial distribution is size 50 and the proportion is 0.1. Because we're dealing with part A, it's then talking about a 5% level of significance. Now the key word here I want to mention is proportion, because that's quite important. When you see proportion mentioned, you would normally be dealing with a two-tailed test. If you're not sure about that, please look at my prior video and that will just explain that to you. So dealing with two-tailed testing, we have to state our two hypotheses, so H0 and H1. H0 here will be that the proportion is 0.1. H1 will be the proportion is not 0.1. That's reinforcing the question because it's asking for a two-tailed test. And we're being told that the probability in each tail should be as near to 2.5% as possible. That's quite important. We divide the significance level by 2. Again, that's covered in the previous video if you're not sure why. So for this question, we're going to pull up a couple of things here. We are going to pull up our tables list so we can see from our tables where 2.5% occurs. So let me just take a second to do that. So here's the tables. I'm just going to delete the ink there to one side just so you can see a bit more clearly, so you can see what's going on. So 50 and 0.1, we're being asked for 2.5% significance. So it's this column that we need, 0.1. This is the sample size 50. We're going to cycle on down our list to find probabilities around about 2.5%. Well, to start with, if you look very carefully, these two probabilities are ones to look at. This is about 3.3%, and this is obviously much, much less than that. We're looking for probabilities near to 2.5% or 0.025. So obviously this is a long way away, and this is quite close. So it's this probability that we need, probability of it being less than or equal to 1. So I'll just state that to one side. And then at the other end, we're looking for, because there's a two-tailed test, we're looking at the other end. So obviously 1 minus this is 0.975. So we're going to go down our list and find probabilities around 0.975. You can see this is quite close. So we're going to look at that possibility particularly. And then we're thinking, well, that's less than or equal to 9. So less than or equal to 9 is going to be the same thing as more than or equal to 10. So remember that from previous videos. So more than or equal to 10 will be 1 minus probability of it being less than or equal to 9. So 1 minus this probability is 0.025. So that's very close to the values that I need. So this is going to be our critical region at the upper end, more than 10, and this is our critical region at the lower end, which is less than or equal to 1. Remember, it did say I need to be as close as possible. So I'm going to rub all these out, and we're going to just go back to the screen and just state those down so you've got an idea about what's going on. As with previous videos, will highlight again what's meant by a two-tailed test so you can see just how this fits together theoretically. So I'll just get rid of this for a second and let's get the pen back. So yeah, let's have a look at the distribution. So a distribution pretty much looks like this. What's happening here is we're saying that the value at the lower end is 1, and the value at the higher end is 10, and this would represent the tail at the top end, and this represents the tail at the bottom end. So these are our critical regions, and this is where our null hypothesis would not be rejected. So that's an important thing to prove there. Now it does say in part B to state the actual significance level of the test. So we've got this one here. I just want to pull up the table once again because we need a table for that. So here's a table once again. It was 0.0338, so it's 3.38%. And that's 2.45%. So you just need to add 0.0338 and 0.0245 together. So I will do that real quick. I've got the calculator here. So 0.0338 and then added to this one. So 0.0245, and that will give me a significance level of about 5.83%. So that will be what the actual significance level is. Slightly above 5%, but close enough. So part C. Part C is talking about a 10% significance level, whether or not there's evidence that the proportion of effective articles is increased. So increase is the critical word here. Increase means it is a one-tailed test, so it's covered in previous videos. It's still a binomial distribution. Again, conditions for a binomial is covered in the previous videos, so if you want to look at that, please do check those out. Again, we're being asked for 0.1 here. So my null hypothesis will be that P is equal to 0.1. And my alternative hypothesis will be that it is more than 0.1. So it's increased. We're being told in the question there are 4 articles. So we're being asked for the probability of it being more than or equal to 4. That's because we're looking for an increase. So we're looking for more than or equal to 4. More than or equal to 4 is 1 minus the probability of it being less than or equal to 3. So we're going to need to look this value up in a table for this particular distribution, or use a calculator, either or. We'll look at the tables today, just because I want to use a bit of tables. Done a lot of calculator work in the previous video. Again, if you want to check that out, it's still available on the channel. So let's just have a look at the tables and find the right one. So this is the 50, obviously, from the previous question. So we need to find ourselves to the 20. So it's a little bit further up the table. This is 40, so a bit more. That's 25, and there's 20. 0.1 is this column here, the second column in. So we're looking for it being less than or equal to 3, 0.8670, 0.8670. So let's just get rid of that. So we can do 1 minus the probability of it being 0.8670. Pull the calculator up and do that real quick. And we get 13.3% roughly. And clearly that is more than 10%. So in terms of the diagram, because it's more than 10%, because we're looking at a one-tail test, this would be the 10% mark, the upper 10%, so it's be 90% here. This would be the critical region. This is more than 10%, so it's going to be lying in there somewhere, so somewhere in the distribution. In other words, H0 is not rejected. We'd need to state that. Okay, that's very straightforward. I'll trash my notations real quick and get rid of the calculator, and we'll move on to the next question, which is question 5. This is actually comparatively quick compared to that previous one, so we're going to look at that real fast. It says it's claimed that 50% of women use Orioles powder. In a random sample of 12 women, 12 said they did not use Orioles powder, so that's 8 women that do. Tested at 5% significance level whether or not there is an evidence of proportion, again keyword, is 0.5. So because it says proportion, it's going to be looking at a two-tailed test here, again covered in the previous video. So what distribution are we looking at? Again, binomial, binomial distribution of size 20, and proportion is testing whether its proportion is 0.5. So that's what we're looking at here. And my two hypotheses will be the proportion stays at 0.5 or the proportion is not at 0.5. We're not interested whether it increases or decreases. That's not stated in the question. We're just looking at whether the proportion is changed. Because we're looking at 8 women here picking Orioles powder, be careful about that, 8 women have picked it. We're looking for the probability of it being 8 women or less. Obviously we're expecting 10, but 8 women, is that in the critical region or not? So we're going to look up from the tables what's the probability of it being less than or equal to 8. So we'll look that up on this particular distribution. I know I've written over it, but hopefully we can see it all right. So we'll just have a look at less than or equal to 8. So here's 8. That probability is all the way over here, 0.2517. So that's 0.2517. So I'll get rid of that real quick. And what does that mean? Well, that's certainly more than we need to be, because we're testing at the 5% significance level. That's 2.5% either way. So again, looking at the two-tailed test and how it works, this would be the lower 2.5%, and this would be the upper 2.5%, 97.5% here. And this region is 25.17, so somewhere in there. So it's really, really in the case that H0 at this stage not rejected. We are going to accept for the moment that the probability is a half. It'd have to be significantly less than 8 to be disproving, I think. Okay, very straightforward. Next one, let's trash my annotations. So I'm going to move over to the other page now. We're going to look at the questions on page 111. Okay, we're ready. Question 9 and 10 now. We're going to look at to finish off both of these on page 111. This exercise, I would definitely encourage you to do the others in this exercise, give yourself some practice, and the answer schemes at the back of the book. Now, question 9, a single observation is taken from a binomial distribution, 30, p. The observation is used to test p is 0.35 or p is not 0.35 against two-tailed testing. Using a 5% level of significance, find the critical region. We're being asked to find a possible region as close as possible to 2.5% either side. So I'll just sketch that down there. So that's important. We're going to look at the distribution 30 and then 0.35 this time. So let's just have a look at the tables. 20 is here. Let's just find our way down to 30. 25, 0.35 is this column, 1, 2, 3, 4 in. So 30 down here, 4 in. Draw an arrow on it, so we've got that remembered. So we're looking at this column here, and we're being asked to find the probability of it being 0.35 or more. So I'll just flick off the table from it because I want to read the question again. So it's saying rejecting tail should be close as possible, so we're finding the critical regions. So let's just go back to the tables. Right, so we're looking for 2.5% members, 0.025. So we want to be as close as possible to that. So you can see already this is pretty close to 0.0255. So that's going to be less than or equal to 5. So we're going to write that down over here. Very, very close, 0.0233. That's quite close to 2.5%. And then at the top end, we're going to look at the top end. So again, we're looking for 2.5%, 97.5%, or as close to it as possible. These two are the two I'm going to look at. Which one of those is closer to 0.975? It's going to be 15 or less as a key statistic. This one here. So that's x less than or equal to 15. Squeeze it in there. Can I squeeze it in? It's going to be 0.96. 99. This pen is really hard to write with. Okay, let's just get rid of the tables for a minute and trash my annotation over here. I don't need that anymore. Right. So that was 0.9699. Now that is actually the probability of it being 16 or more, remember, from previous type of titles. Now remember, we need to look at 16 or more, because that's 1 minus probability of being less than 15. So 1 minus this will give me the actual possibility. So 1 minus 0.9699. Pull the calculator up to get that. And that's 0.0301, so quite close to 2.5%. Okay, get rid of that for a minute. Now, state the total of the actual significance level of this test will be these two things added up, so 0.0233 and 0.0301. So again, just pull the calculator up real quick to do that. And that will give you 0.0534, so quite close to 5%, but not exactly 5%, a little bit more. And then it's asking you to go on to another section, so it's saying the actual value of x obtained is 4. State a conclusion that can be drawn based on this value, giving a reason for your answer. So what does getting 4 mean? Well, 4 is in the critical region, isn't it? Because we said the critical region was between 5 and 16. So again, just to illustrate this, I'll just trash my notations real quick. We had between 5 and 16, so here's 5, and there's 16. There's the critical region, and there's the critical region, and so 4 will be in there. And so that must mean that H0 would be rejected. So state a conclusion can be drawn based on the value, giving a reason for your answer. It's in the critical region, therefore H0 is rejected. So you'd have to accept that P was not 0.35. Okay, trash my notations. Let's look at number 10. So number 10, real quick, the very last one. A pharmaceutical company claims that 85% of patients suffering from a chronic rash recover. Random sample of 20 is taken. So again, my automatic response is to write down the binomial distribution for this. We've got a size 20 and probability 0.85. And we're being asked to write that down. We're not being asked to give reasons, but the reasons for this, there are many. I've gone through in previous videos. Part B, given that the claim is correct, find the probability the augment was successful for exactly 16 patients. So we're being asked to find exactly 16. So this is not a table question because it's an exact probability. So when they're talking about exact probabilities, just go straight through and work them out because we know how to do that. We've done that in previous videos too. So you're looking for 20 choose 16 times probability of success, 0.85 to the power of 16. And then 0.15, power of a probability of failure, so the probability of 4, and again that classic test to make sure these two should add to that. So 16 and 4 do make 20, and you would work that out. So let's just pull the calculator up. And we'll key it in. So 20, choose 16 times 0.85. the power of 16, and then multiply that by 0.15 to the power of 4, and then that will give us an answer. It's 0.1821 to 4 significant figures. The last part says the hospital believes the claim is incorrect, so incorrect, and the percentage you will recover is lower, keyword lower there. So what distribution are we looking at here now? Because the sample size is 30, so it's going to be a different binomial distribution. Sample size 30, and we're being asked to find 0.85 as a success rate. Now this won't be found on the tables, you'll have to use a calculator for this, so I'll do that in a sec. And she's finding that 20 had recovered, and she's being told state your hypothesis clearly, test at a 5% level of significance. So testing the hypothesis that P is 0.85, but we want to test if the probability is lower than 0.85. Okay, that's the challenge. So is obviously 85% of 30 would be a certain number, which you can work out, and then we're looking at that being less than or equal to 20. So we're being asked to find out the probability of it being less than or equal to 20. Is that too low for 85% to be preserved? So as I say, we'd use a calculator to work these out because you can't look this up in the tables. So we're going to just get the calculator up, and then I've done this in previous videos again, but we're going to look at mode 7, binomial CD, this time variable because we only want one variable. We're looking for it being less than or equal to 20. The number size is 30 here. And then a probability of 0.85 is the success rate. What does that give me? So it's a very small number. Very small. I round it to four significant figures. So it's quite small, it's 0.9%, something like that. So very, very small, much less, much less than 5% level significance. So again, just to explain what's going on here, if you were to have a look at the distribution, because we're doing a one-tailed test, this would be 20. This would be the 5% significance level, and then this would be the critical region, and 20 is going to be in there somewhere. So very, very much lower than 5%, much lower than 5%. It's 0.9%, so it's really in there. So that would mean that H0 is in fact rejected, and H1 is accepted. So that's important to do that at the end there. And that would end that particular topic. I hope that was helpful. All the answers to these are at the back of the book, so I would encourage you to go through this exercise in your own time. Those are the questions I wanted to go through for today. Please do spend some time now going through the rest, and hopefully I will see you soon. Thank you for tuning into the Maths Jedi. Thanks very much.